questions are probably the easiest things you could see on the test. So if these are giving you trouble, then you're behind. You need to study hard between now and Friday. Okay, so this first two, it's just rewrites. I'm going to call on different people. Let's go with kid in the front row. This should be easy. I know you're gone yesterday, but you can rewrite, can't you? Okay. Good, and then the other one? 3 squared equals x. You got it, good. Those are the rewrites. Raise your hand if you had those right. Okay, good. Next part, Mr. DS. You're not sure if it's 3 or 1/3. Okay, how about this? Tell me this. You can replace, you're positive it's 3 now. All right, good. And how would you know? Because you could do a rewrite. Tell me the rewrite part. 3 to the x equals 27, yes. And that means you're right. It's got to be x equals 3, because 3 to the third is 27. All right, good. Now, I'm curious, did any of you do this by changing that 27 to a 3 to the third? And then the only downside is you might not be sure, like you weren't sure whether it was a answer of 1/3 or 3 or whatever. But if these two numbers are the same, that's your answer. So it's 3. Okay, on to number 3. Oh wait, I'm number 2. Back to number 2. Who had number 2 right? Okay, good. Miss A.T., what did you do to solve number 3? Nope, I want you to tell me what to do. Nice. Now what? Square root. Square root. X plus 2 equals 3. Did I do that right? Absolute value. How many of you caught that? Awesome. If you didn't, it's probably just, it's easy to forget. Anytime we do an even root, you got to do absolute value, which means there's 2 answers. X plus 2 equals 3. Oopsie. And x plus 2 equals -3. And then this one, subtract 2, x equals 1. And this one, subtract 2, x equals -5. Now, what do you do? Did you give 2 answers? I'm thinking some of you might have left 2 answers there. Why isn't that good? Because one of them doesn't work. I'll prove it to you. Do you get, when I put in a 1 right here, 1 plus 2 makes 3. Log base 3 means basically you could rewrite and do 3 to the second equals 9. That one works. The 1's fine. The -5 is a extraneous answer. It's an answer that seemed right, but when you actually put it in, you get a -3 for a base. Do you remember you're not allowed to have negative numbers there? One more thing I want to add to your list is you're not allowed to have a 1 for the base either. Can't have negative numbers here or here, and you can't have a 1 for your base. Came up in class the other day because somebody was saying, shouldn't log base 1 of 1 be equal to 1 because these two numbers are the same? And it seems like that's true. But you're not allowed to have a base of 1. Here's why. Let's say I had log base 1 of 5 equals, I don't know what. If you type that in the calculator, remember how you can type it as log 5 over log 1? It will fail. It will say, can't do that. Why? Because it knows logs can't have a base of 1. And another way to think of it is, when you do this, you're really saying 1 to the x equals 5. Think about that. Put 1 to a power and make it equal 5. You can't. You get that? That's why we can't have 1s down here. You also can't have any negative numbers in either spot. You also can't have 0s. Think about it. If I had a 0 down here, 0 to the x power can't equal 5 either, can it? 0 to any power would be 0. Okay, so these are supposed to be positive numbers, and one more thing, can't be there, it can't be 1. So positive numbers other than 1. Can it be a fraction? Yep, it can. But it can't be a Positive numbers just had to have 1 as a base. All right, enough of that. So then back to this one. I'm saying this was great. It's great that you knew its absolute value. It's just that when it's all said and done, this one's extraneous. So the answer really was just 1. Now those of you that didn't even notice that there was an extraneous answer, in a way might have been better off because you probably already said the answer was 1. It's just that it was more complicated than that. And this might be one of those smart kid penalty problems where you're smart enough to know there was 2 answers, but then you weren't quite smart enough to know that one of those didn't work. All right, but anyway, 1 was your final answer on that one. Questions? Yes?
How would you write out that only one of the answers with the
I would do exactly what I just did right there. Cross this off and then write ext is why you crossed it off. Okay. All right. On to number 4. This one, if you know the pattern, that if these two are the same, that one's the answer. The answer is 7. You can do it in a fancy way, but it's just a lot easier to know the pattern. All right. Now let's step up. Since we got 2 more days between now and when we'd have the logs test. If it was that easy, how many of you would get an A on the test? Okay, good. And it's not going to be that easy. Why? Because we're just going to add a few more little things. Specifically, let's say that there's more complicated when it comes to fractions. 1 over 27 here and a 3 there equals x, and without a calculator. All right, so everybody try rewriting this puppy. I'm telling you, you can get bogged down in all kinds of other stuff, but if you just rewrite them, they become questions from your last test, the test on exponents. If you can handle making things have the same base as each other, you got half this test. So did you say 1/27 to the x power equals 3? You do this little loop. You got that? Okay, so then now it becomes one of those make the bases the same problems. Do you get that simpler is usually better? So let's just keep the base 3, because then this has a power of 1 on it. It's just 3 to the 1 is 3 to the 1. Let's make this be a 3. That's the challenge, because that is not equal to that. So you figure out that's the process. These have to be equal, these have to be equal, and my bases need to be equal. And they all are. So then the only question is, what do you put right there so that you can make this work? Try it. If you've got it already, turn it my way. I'll tell you if you've got the right answer. I mean the final answer, not just this. You're going to set this equal to this and then solve it. Yep. Yep. Something went wrong on yours. Something went wrong on yours. Yep. Something went wrong. Okay, wait a minute. I'm now getting a ton of. Everybody's got them right now. What's happening with that? Oh wait, yours is missing a negative. Something you had to flip it. Don't forget the negative to do that. Yes. Something's wrong on yours. Something's wrong on yours. Something's wrong on yours. It's weird. That side of the room all has it. All right. So I'm not confident anymore because I'm seeing some smart kids with a different answer than I thought it was. So I'm going to finish this. So the question really was what to put here. Do you get that I need a number that's going to flip my 3? Do you get that? The 3 needs to turn into a 1 over 27. So I got to get it to flip and turn it into 1 over 3. So the first thing is, would you all agree I need a negative? Okay, so some kids didn't have the negative. That was one thing that was wrong with people's. Negative something. Now, would you agree the 3 needs to also turn into a 27? It's just to flip and turn into a 27. So the 3 turning into 27 is 3 to the 3rd. So since some people had the answer of negative 3, well, that is what this is. This is negative 3, but that's not the final answer. Negative 3 is now part of the problem. Negative 3x equals 1. See, some of you got just the negative 3 and you stopped. You need to finish the deal. Divide by negative 3, divide by negative 3. X equals 1/3, and it's negative. Raise your hand if you think you understand that now. Okay, good. Let's move on to a different kind that's very similar. Now the fraction is going to be over on the other side. This is going to be a 4, and this one's going to be an x, and this one's going to be a 32. Nope, that would be just a huge, huge, probably so big your calculator couldn't even do it. As soon as I did the rewrite in my head, do you get that it's going to be 4 to the 32nd power? And that's like a holy smokes, that's way too big. All right, so let's make this a x minus 1 right here. Let's make this a 3. Now you can do it without the calculator even. It's just a rewrite. Just start with a rewrite. Did you say 4 to the third equals x minus 1? And then you don't have to do anything complicated with common bases. So just say 4 to the third is 64. X minus 1, add 1 to both sides, x equals 65. That's it. What if my life depended on it? What would you do? Check it. Put it in there. Make sure it actually works. 65 minus 1 is 64. 4, and then there's a 64 here. So 4 to the third equals 64. Yeah, I think it works. Now, could there be like some kind of a negative number that I could put in there? Like, is there a chance I dropped a solution and I missed one? Could you put a negative number in for x where it is right there? No, because if I had a negative number like -2 and then I subtract 1, it's going to be a negative argument. You're not allowed to have a negative argument. So, all right. How about this? Now, if it doesn't say what it is, like it doesn't have an answer, you could put an x here. If it doesn't have an x in the problem already, you say equals x. You know the answer? I knew it right away. Of course, I wrote the problem, but I knew it right away because I got a dumb little saying for this one. You remember this? Turn it my way when you get the answer. Yep, 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 yep. Not 1, it's the common mistake answer. Because 1, obviously it's important that there's a 1 there, but if you won the argument, you get nothing. That's a 0. So it's a 7.3 to the x, and we're doing a rewrite, equals 1, and then that number is a 0. So x equals 0. Okay. I want to get into the actual notes for today. We're going to skip through some of the review stuff, so I'm going to pause for a second while everybody pulls up the notes for today. Okay, here we are on logs day 4, and we are going to be solving them when you have the x over here. That's one thing we're going to do today. If it was that easy, it'd be really nice, but that's one main thing we're going to do today. Because think about it, if the x is way over there to the right, do you get that this already has x alone, and x is that? So if I can just solve it, you know, like the x is already alone, it's so simple. So this 8 could be changed into 2 to the third, and then right away, I know the answer to that one. What's the answer? 3. Because if the bases, or if these two are the same, it's kind of like saying the bases are the same. It's the base of this log and the base of this little thing. The bases are the same, then the answer is the exponent. Okay. But sometimes, moving up to, they're like this. Now notice the x is still only over here. Okay, there's still just an x over there, but we got to get rid of a couple things. Do you get we'd have to add 6 to both sides and then divide by 2 on both sides? So what would be really handy is if, when you're solving something complicated like this one, that you're able to solve this part and get just a number for it. Because if I got a number for that like 3, it's not 3, but if it was 3, then it would be so simple. 3 equals 2x minus 6. See, it's just like a super simple equation then, right? So the goal for today is to be able to do a lot of these in your head. Not necessarily like without showing any work, but like not having to rewrite the problem. Okay, so let's try to do this one. This is a hard one, but it's not that hard. This 1 over 125, Do you get if I could write that as a 5 to the something? I'd have log base 5 of 5 to the something. And if I had that, the question mark would be the answer. So 5 to the what makes 125? 5 to the negative 3. And then it still equals 2x minus 6. But this whole side, now this freaks people out sometimes, I don't know why, but that whole side turns into a negative 3. Now it becomes negative 3 is 2x minus 6. And then from there, you just add 6 to both sides and divide by 2. Okay, so this whole side, you have to get, you can replace this whole thing with just a negative 3. When we say it's equal to negative 3, that's what we mean. You pull the whole thing out, put in a negative 3. All right, that's the basics of it. So we've already done a bunch of warm-up, so I think we're going to move on to this. We are going to talk about this mostly today. And we're doing a little bit of the review that we're going to do today. All right, so basically the x is over on the other side. It's the exponent position. And this, super easy, 2 to the x equals 8. Come on, that's so easy. What's x? X must equal 3. And again, we could do this one by changing this 8 into a 2 to the third, and then you can go, oh, these two are the same? Answer's 3. And this whole thing gets replaced with a 3. So x equals 3. All right, the solution shown by the teacher will be much cleaner and nicer than what I did, but it's still got an answer of 3. All right, let's look at this one. 1/2 to the x equals 32. You can't get too many fractions. I mean, fractions are going to be on this test all over the place. You've got to know fraction exponents and fractions in general. This is one of those reasons I work on the top 20 stuff early in the year. You guys have pretty much all got your fractions remastered. I knew you had them at one point, but when we came in here, most of you got some of your fraction problems wrong, but now we got them fixed. 1/2 to the x equals 32. Can I do this as make a common base? Yep. What's another way I could have done it, though, instead of rewriting it and making a common base? I could have taken the 32 and rewritten the 32 as a 1/2 to the something. You get what I'm saying? If this was a 1/2 to the some number, then the some number that at the power of it, that would be the answer. So you don't have to rewrite this as a exponential. I have to say I think it's easier to rewrite it. I'm just saying that if you're good at changing these to like the same as this number to a power, it makes it really easy. Okay, so then what's a good base for 1/2 and 32? You could use 1/2, or you could use 2. See, the beauty part about rewriting it like this is you can change both sides to a different number. If you do it where you change this number only, you have to use 1/2 as your base. Okay, so a rewrite is a little better. So there, I've rewritten it. Now I'm going to change them both to 2's. 2 and 2. Now, I've got those parts equal. That's not equal to that, though. That's not equal to that, so I have to do some fixing, and this has to be to the power of x. So I need to figure out what power goes here and here, and when I know that, that times that will equal that. Solve it. Turn it my way when you've got it. Yep, 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 yep. This a little bigger. Yep, that's good. Okay, so this was a -1 because 2 to the -1 makes it equal 1/2. What makes 2 equal 32 is if I put a 5 here, 2 to the 5th. So then it's -1 equals 5, or no, -1x equals 5, and then x must equal -5. Oh, pretty much everybody had that one. Okay, this one we actually I already showed you this one before. It said we were going to kind of work up to this. this part right here, we could rewrite as a 5 to the negative third. Then I have log base 5 of 5 to the negative third equals 2x minus 6. And then the beautiful thing is, it's so simple from there. This just turns into a negative 3. And then I solve it like a fifth grader would solve an equation. Okay. This one is the new one. Look at all the fraction stuff. You see what I was talking about, where there's tons of ways you can do fractions in these problems? All right, what do you notice that is different about this problem? It might be the first time I've ever done this. What's different? Yes? The base. The base is a fraction that has an x in it. Okay, so once again, faced with a hard problem, start with a rewrite. Everybody rewrite this puppy so that it doesn't have a log anymore. It'll just be an exponential. Put this in parentheses when you do x over 5 to the power of 3 equals 64 over 27. Now it just becomes a common base problem. Or does it? No. Can't make those bases common because I got an x in none of the bases. So then, remember, it's all about getting the x alone. Do you think we should multiply by 5, or do you think we should put it to the 1/3 first? 1/3. Got to break it out of the jail first by getting this bars off of here, the parentheses off of there. 1/3 power, 1/3 power, and then you'll have x over 5 equals cube root of 64 is 4, cube root of 27 is 3. There we go. And from here, all we got to do is get x alone. A lot of people say cross multiply. I don't think so. Just multiply by 5 on both sides and you'll have it. Because then x is alone. Can you multiply both sides or cross multiply like this? Yeah, it's legal. It's just you have another step. Because it'll be 3x equals 20. But why don't I just multiply by 5 on both sides and the x will be alone. See? Okay. This one, all by yourself, no calcs. I'm going to pause for a second while you give it a shot. This time, I want you to compare with the person across from you in the row. Rows 5 and 6, rows 2 and 3, and rows 1 and 2. Just compare across once you're done. Okay, how many of you have already compared with the person across from you? Okay, good. That's pretty much everybody. So you should have done, for those at home, 4 over 49 to the power of x equals 2 over 7. And then this looks to me like it could be a common base kind of question. But can I actually make those bases the same? Yeah, because this 4 can shrink down to a 2, and this 49 can shrink down to a 7. So I'd use 2 7ths as my base. And that just means this right now, that's equal, but that's not equal to that. So I check, oh, I need a power there. That needs to the 1/2 power right there. And that, no wait, 2 to the 1/2 isn't 4. Squared, that needs a 2 there, right? Okay, good. So then it's 2x equals 2. 2x equals 2. X must equal 1. Hold on, I obviously did something wrong. Oh, okay. It was over 7. Oopsie. So, sorry, 2x equals, this is the power. So let me get that little, I guess the blue circles won't want to go away. I shouldn't have circled that. This was a 2 7ths to the 1 power. Yes, thank you. So I should have circled the 1. So 2x equals 1. And then x equals 1/2. Now did I do it right? Okay, good. Thanks for catching that. Okay, so this one, it's the same basic idea. And let's see. Oh, hint, this last exercise could have been solved in one step by applying that log property. So, so all they were saying is we could have made this into a 4 over 49 to the power of 1/2. And if we had made this into 4 over 49 to the 1/2, then that would have been the answer. Okay, moving on. Let's skip over that last one. Let's do number 6. This one looks incredibly scary, but it's really not that bad. Right here, just do that part. That part comes out nice. Then do a rewrite. You can even do this part. Again, that part simplifies down real nice. Then do your rewrite and then solve. Mari, can you tell me what those two things simplify to?
Yeah. The first one
Uh-huh.
has 4.
Because you squared it, which makes it 1/4, and then you flipped it, makes it 4. Perfect. And then?
The other one will be here was 6.
Square rooted. Yep, good. And then it's a plus 5 to the 3/6 is also known as a half. A plus 5 to the 1/2 power equals 4. And then, what do I do to both sides? You put it to the power of 2. And then we have x plus, or a plus 5 equals 16. And then you subtract 5, x equals 11. Raise your hand if you had that one right. And most of you are following. That's good. Okay. So, your homework for today. I don't think we need to do those last few. They talk about with a calculator. It wouldn't be bad for us to just talk about the calculator for a second. Let's say we had to solve this kind with a calculator. Hold on. It won't let me hit the back arrow. That is really bizarre. I just want to go back one slide, computer. Come on. Okay, maybe I can do it this way. Okay, now my computer's locked up. Okay, so I can't even add a page. Okay, so I guess I am done with the explanation for now, and it's homework time.